Hi everyone, welcome to lecture 14. In this lecture, I'll talk about lists, how to create lists, indexing and slicing on lists, and a few basic list methods, and we'll also talk about nesting lists. Just like any other object type, list is another object type in Python. We know that whenever we create a variable, it has a type and it is an object. We've talked about integers, floating points, strings, and booleans earlier. Now we're talking about a new object type that's called a list. A list is similar to tuples, and we have talked about tuples as well. The major difference between lists and tuples, as we'll see today, is that lists are mutable. So you can go and update elements in lists, unlike strings or tuples. Lists are ordered sequence of objects, again I'm repeating that, such that we can save multiple elements, and the way we can identify lists is by using these square braces. These elements could be of any type. For example, in this case, you can see 10 is an integer, hello is a string, and then 500.5 is a floating point. We can also save logical values like the booleans as list elements. Lists are the most generalized form of sequence in Python, and these are also called container type objects because you can use lists to store multiple data types at the same time. A single list again can contain data types like integers, strings, as well as other objects, as I said earlier. Now, let's go to Spyder and actually go and create a list. The syntax for any list, and I'm creating a list type variable, is by using these square braces. If I create an empty list, I do not have to specify my elements. But in this case, I'm specifying elements in my list, and this is my new list. I can go and check the type of my new list to make sure that this is an object type in Python. And as you can see on the right hand side, it is of the type list. Now, the important difference between lists and tuples, as I said before, is mutability, and this makes lists really flexible. Lists are flexible because they are mutable. Now, let me demonstrate what mutability is. Sorry, this is a small typo. Let me just correct that. Okay, so now I've created a list called a new list, and I want to go and update one of the elements here. I cannot go and do that for a string or a tuple as we've seen before. We might run into errors, but with lists, we can do that. New list, and I just want to go and update the 0th element. So instead of 1, I just want to assign 7. And this works, as you can see. Now, if I go and say print new underscore list, I should get this updated list. And that's what we get on the right hand side. I can assign different objects to the same name. And this is similar to what we've done earlier with tuples and strings, right? With the same name, I can go ahead and assign, let's say, a new string. So basically having elements with different values, and then 3, 6.8, and so on. And this object also gets created. If I go and check the print, I should get the new one. So this goes back to our discussion of dynamic typing, where we can always go and update a variable, right? So it is similar with lists. So some of the important functions that we can use with lists, just like with tuples. The first one I'm showing here is the length of a list, because this is something extremely useful. We'll be using it throughout. Again, len new underscore list, and this tells me the number of elements that list has. Next is the before the concatenation, let's talk about replication. And then again, replication and concatenation work the same way as with tuples. Let me show you repetition, which is new underscore list is equal to, I can go and assign some new value. So let me go and assign it some new value, 1,3, and then I'm saying go and repeat it, let's say 3 times. Now go and print this new underscore list. Let me see what I get. Now, as you can see, I get these elements repeated 3 times and I get a new list with all these elements. So this is replication, similar to what we did with tuples. Now let me go and create just list 1, another variable, another list in which I have these elements A and B. And then let me do this, print list 1 plus new list. This was our previous list. And as you can see, I get the concatenated version of my list. So this is the concatenation operator, similar to the way we did in tuples, right? Now let's talk a little bit about indexing and slicing. Again, if you're familiar with indexing and slicing in strings and tuples, it's pretty much the same in lists, but it's a bit more useful because you can go and do a lot more with lists. So I have a new list already. Let me go and grab the first element of my new list. The way I do that, just like with any other iterable, similar with lists, this is my first element, right? Going back to my new list, remember, this is my new list here, as you can see on the right hand side. And the first element is 1. I can grab index 1 and everything after it, which is new list, and then this is slicing. We've done that earlier. I have to start from element 1 and I want everything after that, right? So element 1 is 3, going back to this highlighted portion, and then the rest, all the elements. I can grab everything up to, let's say, the third element. So the default is starting from 0, and then this is what I get, right? So it begins with 0, but up to the third element. Remember how slicing works? Let's go back and think about it. So this is the 0th element, first, second, third. So I'm getting 1, 3, 1, which means that slicing would skip this where I'm trying to stop, right? So it skipped the actual third element. So it's getting me everything up to the second element. Another important thing to remember when working with lists, or in fact any other iterable, is that if I go and get, now I just want to go and get the, like, let's say 5, right? Go and get me the 5th element of this list. And this is the 5th element, right? If I just go back and count this 0, 1, 2, 3, 4, 5. And if you're trying to go beyond this, which means 6, this would error out. It will say list index out of range. So whenever you see this error, you should be able to figure out that I'm trying to access an element that does not exist in my list. And you would usually get this error when you're saying new list, grab the element, the length of new list. And this should be by now clear why I get this error. And that is because the way length works is it starts counting from 1, and my indexing or slicing is working from 0 and so on, right? So if I'm really trying to get the last element, one way of doing that is length of s minus 1, or simply minus 1 would also work. So that gives me the last element of my list. And that's 3, right? Okay. We can create, let's say, new underscore list 1 by using an existing list, which is my new underscore list right now, plus concatenate it with some new values. And this works. Let's say this is n, this is 70, this is 56, and this is my new list 1. And let me go and print this. Print new list 1, and this is what I get. So this is another way of concatenating. And similarly, you can do replication by actually defining a list like this and then multiplying it just like we did here. Or you can have an existing list and multiply it by 3. So repetition or replication works similarly. Now let's create another list and look at a couple of functions. In Python, you might want to go over and look at each of these that I've listed here. If you have the time to, we will look at some of them, but not all of them. I would recommend that you go back and check how each one works, because these are extremely useful, especially when we start working with loops. Okay, so going back to Spider, just list a few methods with lists. The first one is, let me actually create another list, ls1. Let's say I'm calling it ls1. I'm saying 1, 2, 3, 4. This is my list. Okay. The first method that I'm talking about is append. This is extremely useful, especially you'll see when we start working with loops. Append is going to append an element to this existing list. Let me show you how this works. So I'm asking it to go and append an element, let's say 5, to my ls1. This is what it means. Okay, let's go and print ls1 to check if I appended the element, and yes, that's there, right? I can insert elements, and insert method actually gives you the flexibility to insert it at a certain position. Like in append, this element would be added at the end of the list. But with insert, what I can do is I can say go and insert at some position, which is, for example, let's say 3. Go and insert 100 at position 3 in my ls1, right? Let's see what happens to ls1 now. This 100 is inserted at the third position, right? Now there is another important and extremely useful method that we use a lot with list, and that's called dot pop. What it does is it removes the element from my list, which is ls1, right? Let me show you how this, and the good thing about ls1.pop, which wasn't the case with append or insert, is that it actually returns an element also. It shows you what it popped, right? So this is ls1 popped the last element. Now let's go and check what happened to the original list, which is ls1. That element got removed, right? I think I wouldn't go into the detail of dot pop. Dot pop can also be used by giving you the position of what element you want to remove. For example, right now my ls1 is this, and I want to go and say pop the element at, let's say, position 3, 0, 1, 2, 3. Let's go and check this, how this works. Right, so it popped the element at my index 3, right? There is another method, and be extremely careful while using that. It's called remove. The way remove works is that, and you will get it in this list, so you can always go and check all these methods here. ls1.remove is similar to pop, with the exception that in pop I'm trying to give the index of the element, and if I don't give any index, it would just pop or remove the last item. With dot remove, I can actually give the value of the element that I want removed. Let me go and create this so that this becomes like explicit as to what I'm trying to say. 20, 30, let me go and recreate ls1. Now I'm saying go and remove the value 20 from ls1. That's how remove would work, and that's how it's different from pop. This is extremely important to understand. And the other major difference is that it's not returning that value just like pop did, right? When I said ls1.pop, it was also showing me as an output the element that it popped. But with ls1.remove, I did not get any output. So what I have to do, ideally speaking, is that go and print the list again to check if that remove happened or not, right? So these are some of the important methods. I would definitely recommend go and check count. So with count, you can go and count the element just like with strings. Go and count this element in this, how many times it appears in this list. Or if it does not, then it would return a -1. Similarly, there are other methods that I earlier showed. Clear, index. Index would return the index of a certain element, obviously. I will talk about sort in detail in one of the lectures when we begin talking about loops. But go and, in fact, let's talk about it right now, because sorting is something that we need to know before we actually start working on loops. So go and explore the other methods. I would talk a little bit about sorting here. As the name suggests, I can go and sort my list in certain order, and that's what sorting means, right? And then there, if I have strings as elements in my list, then I can sort in alphabetical order. And the way this works is it's also called lexicographical order. If I have like uppercase and lowercase letters, uppercase take the first precedence and then the lowercase. With numbers, we know what sorting is. They would be arranged in ascending order, right? So let me show you, and in fact, let me go and create my my list as another list to make sure that we understand the idea of sort. And I have these elements saved here in some order, obviously, and I'm saying my underscore list dot sort, and I'm not giving any input to my sort, right? As you can see, first of all, dot sort does not return any output. It does not give me anything. Let me go and check what happened to my underscore list. My underscore list is sorted. Important thing to remember is that dot sort changes the input. So it changed my input list. This is a method that changes the input, right? My list got changed. Now let me go and create or repeat again my list. I don't know how to come up with a new number. Let's say I have these words and I'm using dot sort. Let's see how it works with like strings, right? Apple, door, right? The way this sort would work is that it would look at the first alphabet of each string and then it would try to sort them in alphabetical order. If one of them has an uppercase, that uppercase would come first. So that would take precedence. Let me show you what I mean. Right? So it is sorted like apple comes before cat because A comes before C. But D took precedence because it was uppercase. If this was lowercase, again, let me show you. Then it would be sorted something like this. Apple, cat, door, because that's how the alphabetical order is. A comes before C, C comes before D, right? Okay, another function that we need to know when working with lists is called sorted. And there is a fundamental difference between sorted and sort, as we'll see. Now, the way sorted works is that I would just go and say my list, my underscore list. Let me go and create that again because now it's sorted right now. So I would just like unsorted and then I will use this function. Now you can see I do get this sorted output, but if I go and print my list, which was my input list, right, that would not be changed. And that's the fundamental idea behind dot sort and sorted. So now it depends on you, like what do you want your input to become? Do you want the input list to change or do you just want to output the sorted list? This is something that's important to remember whenever you're using sort and sorted. Okay, and last in this lecture, I would give you a little idea of nested lists because these are extremely useful when we are working with loops. Nested lists, as the name suggests, is nothing but list within a list. So I can create a list. Let's say this is my outer list, and then within that I can have multiple lists. That's all, separated by commas. And how do I know that these are lists? Because they have the square braces, right? And so I have multiple lists. This is like lists within lists, right? So one, anything, and of any size. That's also important, right? And then just go and print L. This is a nested list because it is list within a list, right? The only thing that we need to remember here is that the way to access the elements would be something like this. Let's say if I'm trying to access 7 here, right? I have to go and check what position is my outer list. Now, if I think about L, my first list is at position 0. This is at position 1 and this is at position 2, right? So let me go and access this list first, which is at position 1, and check the output. So I get this list. Now I'm trying to access 7. I know that I can access the list within which 7 is saved like this. Now how do I get to 7? Is by using another square bracket and then checking the position of 7 within this list, which is 0 and 1 again, right? And this is how I get 7. This is how I access elements within a nested list. We'll talk more about this later in some later lectures. A few more important functions before we end this lecture is using max and min with lists. So just like with tuples, max would return the maximum value of a list and min would return the minimum value in a list. For example, in fact, let's go and check, or just like create some list and then check the output of max. As you know, this should be 67 because that's the largest value, and then min returns 4. So these were the things that I wanted to talk about when introducing lists today. In some of the subsequent lectures, I would talk more about lists. Another thing I think that I forgot to mention was sum. The sum function also works well with lists, just like with tuples. You can just specify the elements in the list and it would return the sum of those elements. Okay, so this finishes our lecture 1 on lists. As I said before, we'll talk more in some later lectures. Thank you.